Good morning and welcome to the STS-61A post-landing press conference. With us today for the conference is NASA Administrator Jim Beggs, NASA Associate Administrator for Space Flight, Mr. Jess Moore, Dr. Herman Strube, Department Head of BMFT, and Mr. Norbert Kina, Head of the Space Project Department of DFVLR. Mr. Moore, Dr. Strube, and Mr. Kina will have opening statements, and after those opening statements, we'll start with question and answers from Dryden. Please remember to wait for me to recognize you, and wait for the mic, and remember to give your name and affiliation also when you're recognized.
Mr. Beggs.
Dr. Moore. I think I'm going to make a couple of opening remarks here, and then I think we'll all sit here and allow you to ask your questions. I'd like to say that, needless to say, we are extremely pleased here this morning with the successful completion of the Challenger mission, this being the 22nd mission in the Space Shuttle program and the 9th flight of Challenger. This mission, as other missions have done, has clearly demonstrated again the value of having humans in space operating with machines such as the Space Shuttle. The teamwork that's been displayed here during the past 7 days by the Americans and the West Germans has just been outstanding. A lot of extraordinary interactions has taken place between the Operations Center in Oberpfaffenhofen and Houston, and then on the shuttle. An enormous amount of what I believe very valuable scientific data has been collected. We operated, as you know, for round-the-clock. Crews were split up into two teams operating on 12-hour shifts, and the mission has just gone with that kind of a plan in an outstanding fashion. I think the cooperation that's been exhibited on this flight and preparing for this flight and actually conducting this flight has been really good, and it bodes well for our future cooperations with our friends and colleagues from West Germany. The orbiter Challenger came in on time this morning. The bird looks in good shape. We rolled out at about 8,400 feet on the runway. Brakes look good. We did exercise nose wheel steering, and I did talk to Commander Hartsfield this morning. He said it felt very good. We are going to have to go back and look at the flight data that's been recorded on board before we'll really be able to do a final assessment of it. But as of our preliminary indications, we were very, very pleased with the results of the nose wheel steering test today. I also can't really say enough for Commander Hartsfield and the 7 other people on board this flight, showing again that payload specialists from different nationalities can work with our astronauts in the shuttle program and pull the mission off with as much teamwork and as much accomplished as I think has been accomplished during the past week. Needless to say, we're very pleased with it, and I'd like to ask my colleague, Dr. Strube, if he'd like to comment on the flight.
Well, thank you for giving me the floor. I would state at this moment that we in Germany are very satisfied with this mission, and we highly appreciate the performance of the shuttle, and we have to thank for it. At the moment, as driving a shuttle is not yet as driving a bus, but we are already nearby. I think this should be underlined, what a good performance the Challenger crew did for giving good occasions and good conditions for the payload crew to work, and to work continuously, and to arrive at a point where we can say that this mission was a very good success, a beautiful mission with a lot of scientific work, which gives us, our scientists, now data to work on to prepare for further missions, because Germany would remain on using the shuttle and shuttle system and space lab system. And I think after this mission, we feel that we are on the right common way to go together with further missions and to look into future where we have the goal of a common space station. We are preparing, actually, together in Europe, European Space Agency on the European side with its contribution, Columbus, to the American space station. And this is one of the first phases we did in this direction. Thank you very much.
Mr. Keenan.
Well, how does one count a success? Any statistic will not give a good answer, but nevertheless, I would like to give a few statistical data. We had on board of this mission 76 separate scientific goals, which we called experiments. In fact, there will be about 120 experiment runs on board. Only one out of this high number has not been performed as planned, and only one will not deliver the data that the scientists need for evaluation. We had a very highly motivated crew on board. They closely and in a good manner cooperated. They were able, together with the support of our ground stations, to overcome the technical difficulties that we had in the beginning of the mission, and thus even showed that the success is higher than 100%, because we did not only do the experiments, but we also were able to show that the crew on board is capable in fixing difficulties and problems. I think that with the outstanding performance of the STS, the Space Transportation System in this mission, and with our payload, we all can be proud on the success, especially here this country can be proud on the performance of NASA and their co-workers. I think we in Europe can be proud of what we did. I would like to thank all involved parties for this.
All right. We'll now start with Q&A from Dryden. Could you wait for the mic?
Roy Neal, NBC News, for Mr. Beggs. Jim, first of all, just a basic question. Is it STS-61A or just plain 61A? Are you still using that appellation? Then I have my main question. What are we doing?
No, we're still using that STS-61A routine.
I was just curious, because as you know, we went through that whole numerical sequence some time back. Now, basically, where does this take NASA? Obviously, it's a major step forward, but where does it take you?
What it does, most importantly, is to illustrate the ability to work with a very broad international group of experiments in an integrated system, and to do that in a way that gives us no problems. This mission was under planning, I think, for 7 years, or maybe even longer than that. And it was, if you will, an experiment in experimenting, in that we're trying to put together a number of different things from several different countries. The mission, of course, was paid for by the German government, and they were directly responsible for it, but they integrated any number of different things, both from the United States and from other European countries, into the laboratory this time. The fact that we were able to do that, as Dr. Stroop said earlier, is a precursor to what we intend to do in the space station. And so it is, if you will, the beginning of our work to learn how we can do these very complex missions and perform. I think there was something like, correct me if I'm wrong here, just 77 different experiments on board. And in fact, we're able to do that and pull it off with as Mr. Keenan said, only one problem, only one experiment had problem. I think gives us a lot of confidence that we can proceed to the space station era, where we will be operating with a number of different countries on a continuous basis.
Lee Dye, Los Angeles Times. Dr. Stroop, when you get back to your homeland, what specifically will you be doing to try to encourage a greater role by the European community in this growing international space program? What we have to do when we are at home is to prepare next mission with an international involvement in Europe and together with NASA. And we hope that the coverage of the media, the positive coverage of the media by this mission will help us to do so.
Scott from CBS News. You didn't hear the first part. Bob Scott from CBS News. Either Dr. Stroop or Dr. Kina, you wanted an extra day in space. What was not accomplished by the fact that you didn't get the extra day in space?
That's not completely correct. We did not request an extra day. Years ago, we had discussions about an extension of the mission over 7 days up to 9 days. The material science experiments, of course, want to get as much time as possible for their experiments. But the technical layout of some instruments for life science experiments did not permit an extension without decreasing the outcome of those experiments. And therefore, we had to trade off whether to extend for the benefit of material science or for the benefit of material science, but against the life sciences. We finally decided not to extend, not to request an extension, not only because the shuttle resources might not have permitted that, but because of having achieved all scientific goals. We have done more experiment runs than foreseen in the plans. We were able, because of the excellent technical performance of the system, to run in parallel material science experiments with the vestibular slat experiments, that instrument that moves back and forth in the space lab module. The disturbances were much lower than expected, and so we could perform material science experiments in parallel and thus get everything performed, although we had some delays in the beginning with the build-up of some of the instruments. We have performed all runs that we could perform, and therefore there was no reason to extend the mission.
Roy Neal of NBC again. This for Jess Moore. Jess, can you discuss the nose wheel steering for us this morning? What was done, what was accomplished, and where that takes you next?
Let me give you what we know today, Roy, in a very preliminary fashion. The objective of the test was to steer the nose through the general-purpose computer on board, and we were to activate nose wheel steering at about 110 knots after the nose wheel had touched down. We were to veer off about 20 or 30 feet off center line, hold that for some time, then steer back to the center line, and then come to a stop. Based on the helicopter looks at the runway this morning, we know we did some steering, and I did talk to Commander Hartsfield about it, how the steering worked. He said it responded very well and so forth. We don't know exactly at this point in time what the track really looked like, and we're going to have to get the flight data and probably go out and take some more detailed looks at the runway and correlate that before we have a final observation. But today we're optimistic that things work very well, and we hope to implement it in Columbia's flight coming up in December and go back into Kennedy in the December flight. Is going to be on Atlantis, and we have not had the opportunity, given the flow of Atlantis, to go in and mod it with the nose wheel steering box. So the next flight we will plan to land here, and that will be landed here in early December. 3rd of December, I think, is the nominal plan for that landing. And then the Columbia's flight, which will be its first flight after a long mod period, as you recall, will have the nose wheel steering box. It has been checked out. It has been modded. And so the December 20th launcher, we're looking at actually backing it up a few days so we can land before Christmas. The December launch will actually fly nose wheel steering, and we will plan to bring that one back into Kennedy Space Center.
Doug Anderson.
Yeah, Dennis Anderson, AP. What is the difference, Jess, in the medical examination that some crew members are undergoing today here at Dryden?
I'm not sure I understand what you mean by the difference. All the crew, as you saw, egress from the orbiter in good shape. There were medical experiments that require that we understand their readaptation back to Earth's gravity environment here. So they're actually undergoing some medical checks now, and we normally do that on all our flights to check and make sure that the crew is readapting back as far as medical experiments. From our standpoint, and let me ask Dr. Kina to comment regarding any of the particular experiments that they might have from the German standpoint.
Well, you know that we have quite a number of medical experiments on board of this mission, and we have performed extensive measurements, medical measurements before the mission with some of the crew members, have taken similar data during the mission and want to get comparison data now after the landing to find out what the change is between the one gravity environment, the microgravity environment, and back to the one G environment after landing, and what the change in time is. And therefore we're doing additional tests which are added to the usual medical investigations.
Dan Blackburn, NBC News. This is for Jess Moore. It looked, may have been the camera angle, but it looked after the Challenger was on the ground that there was a more scorching than we've seen on some on the nose. Do you have anything on that? I think your observation is correct. There were some kind of deep orange-looking colors up over the nose area and also over the cabin windows, and we saw a little bit of that over the wings. We looked at the tiles, or at least I saw the tiles from a fairly close-up television shot, and it didn't look like we had any tile damage. So one suspicion that we're looking at right now is maybe some waterproofing effects that might have caused that discoloration. The thing that leads me to think we didn't really have a major heating problem or heating concern on this flight is if you looked at the discoloration, it was very irregular. It was not streaked like I would expect if you were getting some kind of a heat leak back in there. But that's speculation right now. Until we get our experts on the tile to go take a look at it, right now we'd say we think it's probably an effect of the waterproofing that's on Challenger.
Tim Harrell with City News Service. This is for Jeff. How much did the West German government pay for this mission, and was this the most expensive mission so far as another either government or agency paying for it?
Yeah, today we have not. This was the first dedicated to a single commercial operation or to a single government that we've had a dedicated flight. Most of them have been to a commercial single satellite, which takes up part of a flight. The actual cost that West Germany paid NASA on this flight is about 60 to 65 million, I think, for the transportation charges. I think that was the number. I think that's approximately correct. 64 million.
Okay, we're going to now move to the Johnson Space Center for questions.
This is JSC. Our first question from Mike Meacham, Gannett News Service.
For either Jess or Dr. Keenan, whoever can answer this, what is the schedule now for bringing the crew off? I understand some will go to Kennedy. And what is the schedule for bringing the medical experiments off? What is the time sequence that's going on there, please?
Well, I can't give you very exact times and hours, but we want to get the crew, those crew members that are involved in the medical experiments and the samples from life science experiments over to Kennedy Space Center as soon as possible, and that will take place sometime today.
Also, one on the nose wheel steering. Am I correct that Commander Hartsfield veered to the left and then came back to the center line?
There were some indications, Mike, that I saw from the helicopter run that would say that's correct. But again, there were some tracks out there that were pretty obscure in places, and I really had a hard time in watching the helicopter track down the runway following exactly what the veer path was. So it's premature at this time to say exactly what happened in the veering, but I do know that the steering was activated and there was some nose wheel steering that did take place during the landing.
We have no further questions from JSC. We'll go now to the Kennedy Space Center.
Jerry Hannafin, Time Magazine. First one for Mr. Moore and a second one and follow-up for Mr. Beggs. Mr. Moore, do we have the HUD, the heads-up display now operational in all four birds?
We're planning to fly the heads-up display on the Columbia flight coming up, and our long-term plans will be, assuming everything is working fine and we're very comfortable with it, to put it as an operational element in the program.
Hey, thank you. Mr. Beggs, I wonder if you would try to respond to a kind of a perspective-type question, to answer perhaps a question brooding on the campuses of this country, and explain what good is the shuttle? What is it good for?
I'm glad he asked you, Jim. Well, I can give many answers to that, Jerry. As you know, I give speeches on this, but let me try to summarize. The good, I think the most important good is what it does when it flies. That is, it makes us, I think, all proud, and I think it as well motivates our young people when we do things like we've done in this past flight of experimenting in space and doing things that give them the promise that one of these days, as they get to the point where they will enter the workforce, that they can anticipate that they will be taking off from a very high plateau, and they will have the opportunity to live and work in space and do good things. Now, more concretely, for those that worry about material blessings, and they are important, as we all know, in this country, the returns that we are getting off the shuttle program, both from a science point of view, from a technological point of view, from the point of view of extending our reach in the commercial arena, are very large and will get larger as we go along. It's been estimated by some of the best econometric concerns that our past efforts in this behalf or in that area pay off in the order of 20 to 30% a year on the investment we make in space, and I believe that's probably understated, but it's hard to trace the flow of technology into the economy generally, but you can be sure that much of the technology that was developed in building the shuttle and much of the technology we continue to explore as we fly will find application. One of the things you don't even think about, for example, is every time we fly, we get more data on hypersonic flight at high altitudes. One of these days we'll be flying hypersonic vehicles around the world, and it may be that our children will fly in vehicles that will reduce the stage time from New York to Tokyo to a couple hours or so. In any event, there are many, many applications that will derive from the work we're doing on Shuttle that will find their way into aeronautics, that will find their way into electronics, that will find their way into the computer sciences and so forth and so on, and all of those yield real benefits to us here on Earth. Third, of course, are those aforementioned commercial activities, and we're all aware that the communications satellite business is now one of the fastest growing businesses in the world. And what the shuttle allows, I think, will provide a profound difference in the communications industry and the way it operates from space. What it has allowed to the present is to create what Marshall McLuhan told us was a world village or world community, and indeed it is making that more possible every day. But what the shuttle allows is to make those facilities that we have in space for communications purposes, for purposes of observing the Earth and other uses, almost permanent, because we have demonstrated, if you've been watching us, and I'm sure you have, but if the public has been watching us, we've demonstrated that we can repair and maintain in orbit. And that is a profound difference from the past, because in the past we've launched satellites, they live for a few years, and then they die. Now we can make them near permanent, because we can go up, replenish the consumables, repair them, replace electronic modules, update them, and so forth, and make them near permanent. That will be a profound difference in the commercial world. In addition to that, of course, we're learning more and more as we fly the material sciences and what can be produced in space. Not only what can be just produced in space, what can be produced in space and duplicated on the ground, but also those things which can be produced on space and used on the ground. And all of those things will yield enormous benefits.
Chet Leonard with Florida Today. A somewhat more mundane question for Jess Moore. Jess, you said you're going to have to study the results of the landing gear or the nose wheel steering. When can we expect a final decision on the return to KSC?
Well, I would expect to have some good indication of the flight data on this thing within approximately a week or so. And, we don't have to make a final decision on this until later on in December, but we're all anxious to see what happens. So as soon as we're able to determine what the runway situation looks like and look at the flight data, we'll be able to make that determination. And I would say it's probably within a week, approximately a week.
Bill Harwood, UPI for Jess Moore. Jess, Larry Bourgeois said last night that a second nose wheel test would be required, and this was reiterated by some of the public affairs world of NASA today, which of course would mean that you wouldn't be able to get back in here in December. Are there two schools of thought, or if these test results are successful in your mind today, do you definitely come back to the Cape, period?
If the test is fully successful, meets all our objectives, today we're planning to come back into the Cape. I have not been appraised of any concern about doing a second nose wheel steering test. That could certainly be something we want to do in the event we have some concerns about the results today, and I think it's premature to make that conclusion. But I'll just say the bottom line today is we're planning to fly into the Cape in late December with that particular launch, and assuming we're happy with the results we've gotten from this flight, that's going to be our baseline plan.
Rob Navius, UPI Radio Network. Two questions. First for Jess. I believe you've just finished your latest evaluation of what's going on at Vandenberg. Can you update us perhaps on the Vandenberg situation and what hills perhaps remain before the March 20th target?
Well, on the Vandenberg situation, as you well know, Rob, we are planning for a March 20th launch date out of Vandenberg, and this will be our West Coast facility, launch facility in the shuttle program. Prior to that, we are planning to do a flight readiness firing in the early part of February to validate the orbiter system facility interface. And so that is the current plan. We have had some discussions with the Department of Defense, and those discussions are continuing. And right now, our baseline plan is to launch on March 20th. I will say that the schedule is extremely tight, and we're going to continue to monitor progress toward meeting that schedule, but we are not prepared to announce any change to the Vandenberg launch date at this time, and we're pressing on for March 20th.
And for Mr. Beggs, you're wrapping up what obviously is a highly successful year. By the end of the year, you will have doubled your flight rate over 1984. But 1986 is a whole different bag. Could you address perhaps the challenges that lie ahead in 86 in what some have suggested will be the most challenging year since the moon landings?
Oh, golly, I could go on all day. It's going to be an extremely challenging year. It's going to be an extremely exciting year for the space program, and I hope everybody watches it. From a space science point of view, it's going to be probably the most exciting year we've ever had. It will start in January with the Uranus flyby by Voyager 2, which takes place on January 22nd. Then in March, we will carry the Astropat platform up to take a close look at the Halleys and learn a lot about the Halley's Comet. We will also be copying on our Deep Space Net all of the data coming back on the various probes that are going to the Halleys, the European probes, the Soviet probes, and the Japanese probes. In April and May, we will launch two very important scientific spacecraft, one of which represents great international cooperation again. That's the Ulysses, a European spacecraft, which some people will think we're a little daft because we will launch that towards Jupiter with the intention of going to the sun. The reason for that is to use the gravity field of Jupiter to throw us over the poles of the sun. So for the first time, we'll see the polar regions of our sun and get some idea, some scientific data into what happens in the polar regions of a star, which is an item of intense scientific inquiry. Also in May, June, we will launch the next probe outside the asteroid belt going back to Jupiter. That's Galileo. We'll put an orbiter around the giant planet and a probe into the Jovian atmosphere. So for the first time, and that too represents large international cooperation. There are, I think, 6 different instruments on that that have contributions from Germany and several others which have contributions from other countries. The Germans are also providing the retro propulsion system to put the probe into the Jovian atmosphere. We expect that probe to live down to about 2,000 Earth atmospheres, and so we will sample the primordial gas that probably was the same material from which our own Earth was created several billion years ago. So that's exciting, and we will get very interesting scientific data there. Then in August, we will launch the Large Space Telescope, the Hubble Space Telescope, and that too is a large international collaboration. The Europeans have supplied 15% of the funding for that, and will enjoy 15% of the fruits of it by using 15% of the observing time. That telescope will be the most important astronomical instrument probably ever put into operation. We will be starting to look out into the universe 7 times further than we can peer from Earth. And then in December, on the way to Jupiter, we will fly by a large asteroid called Amphitrite, if we do everything just right. And so for the first time, take a look at a big asteroid, which is of quite some scientific interest as well. All told, we will launch the shuttle 14 times, and we expect that many of those, in addition to the Astro platform, will carry pieces and parts of the space lab or entire space labs. So that means we're going to double our flight rate again, or close to it. And it is a very challenging year. I think we are on track, though, when we can pull them off as perfectly as we did this one, and I'll knock wood, that we will do just as well next year. And I trust that we will, because we're learning quite a lot now, and we have learned how to turn the vehicles around. We've learned how to put them into operation in space, and we will next year start to operate with the full Uptedra system, because the next of the tracking and data acquisition relay system satellites goes up in January. So we're going to have, I think, an exceptionally good year. And I might add, if the school teacher goes up in January, and one of the journalists, perhaps one on this net today, will be flying probably in September or October. We hope, assuming we can find just one out of all those people that are going to fly.
Okay, we'll take one more question. Kate, and back to the side.
This is Howard Benedict, Associated Press for Jess Moore. For those of us who would like to make some Christmas plans, what are the odds that you can move up that 61C flight, and how far in advance could you move it up?
I thought I was going to get away with this press conference without having to address that question. Let me say that in our November flight, I'll start with the November flight, we've been able to back that flight up by some 12 hours to an evening launch. We're going to launch it on the 26th of November at like 7:30 at night. We have KSC currently looking at moving the December 20th launch date back by a couple of days to the 18th. It's nominally planned for a 5-day mission. That would mean we would get down on the 23rd, and that would make us happy. And that's what we're working toward, but I can't sit here today and say we're going to meet that. I'd like to minimize all of our shuttle team, who's worked exceedingly hard this past year to double the flight rate, and we've got a challenging plate ahead. I'd like to see us be able to not be flying during the Christmas holidays and have some time off. All the people have spent many, many hours working to make this year as successful a year as it's been for us.
Okay, we're back at side.
The German Amateur Radio Club had some amateur radio experiments on board. Can you give us a fill-in on anything that might have happened there? I know they were performing, but I don't know how they performed or who talked to them.
If I may answer to that question, this was not one of the scheduled and official experiments on board. It was something left to the crew within their time off duty. They have done that, but I'm not aware of the details and how successful they were. We have to evaluate that after the mission. Especially here in this country, we were not aware of what was going on over in Germany and Europe.
Jack Popejoy with KCOP Television in Los Angeles. I believe, Mr. Kina, you made a reference earlier to the media coverage in Europe. recognizing you've been away from home for a while and in this country, can you give us an idea what the reaction has been, what kind of coverage you've gotten, and what that means for the future?
Well, of course, I have not been over in Germany during the mission, so I have no direct personal impression of that. But having talked to our people over, there was a very, very high coverage, a very high awareness in the public of what was going on, and that was not only true during the first days where we had some minor difficulties, which of course also are always of interest in the public, but even during the last days when everything went very smoothly, there was a very high interest, and I would compare that with the awareness of the public in Germany when the Enterprise first went over to Europe. It stayed for 2 or 3 days in Cologne, and we were expecting perhaps some 10,000 people. There were 100,000 of people, and our roads around were blocked through that traffic. That means there was a very high interest, and I personally expect that this will push the public interest for space activities. Mainly, of course, it is due to the men involvement in this endeavor.
Well, I think this is really one of the main things. When men is involved, then people, you can shake hands after when they are back, you can speak to them and you can interview them. This is something of kind of adventure still ongoing, and this people likes, and the media are covering this much better than other things, with the exception of some accidents.
Penny Durham, freelance. I had the impression watching the landing that the rollout was much shorter than usual. Am I correct?
That's not true. The rollout was about 8,400 feet, and we've had rollouts shorter than that actually before. Some of our rollouts, however, have been 10,000 feet, so that's not out of the family of our experiences to date.